Here we are going to talk about index. So earlier we talked about the general database structure and also their access method, including the ordered table and unordered table, the binary search, and also the linear search. So those are, you can say, kind of like the traditional way to organize the data in the way that the access of the data can be more efficient, and then by reducing the input, the I/O, the input and output time. But however, the more modern way to improve the query performance of the database is by using index. So, why do we need index? Why physically organizing the records on the disk is not enough to solve the performance issue? The reason for that is, as you can imagine, the previous example, the weather data example, we ordered the records according to the temperature readings. But however, right now, if on that data, if we want to set a query or with a query criteria that to search data, you can say well in a certain time period. For example, I want all the data readings from 2022 March 15 to March 16. Then in this case, the table is physically managed according to the order of the temperature, but however, it's not according to the order of the time points or the time attributes. So in this case, in order to find the records, it still need to perform the linear search because according to the time attributes, the table is entirely an unordered table. So for an unordered table, we still need to perform the linear search. So in this case, that means this type of purely physical organizing of the records on the disk, it cannot solve all the performance problems. Of course, it can solve a specific type, or you can say a limited type of query performance problem, if you can guarantee that all the query that you need is on the specific attributes. Then in this case, you can try to order the records physically according to those fields. But however, if it's possible that the user wants to query according to other attributes, then you still need to perform the linear search. So that's why the traditional solution is not enough. So in this case, in the modern solution, the indexes are the primary mechanism to improve the query performance for most database management systems. So the concept of the database index is very similar to the index to a book. So for any like you can say textbook, if you turn to the like very last few pages of that book, then you will find a certain the index of that book. Then you will have some keywords list over there, and then with the page numbers that those keywords appears. So if you are looking for a certain keywords, then you can directly go to those pages and then to find the content that you need. So the index to database is very similar to that. So let's give you an example. So by the definition, so an index is actually an ordered table with two fields. The first field is the index field, that the ordered value, that is the ordered value of the indexing field. And the corresponding field is the pointer field. The pointer field, it contains the address of the disk blocks that will link to that particular that will have the particular index value. Okay, so let's take a look at the example to help you to understand this. So as you can see, here is the you can say the raw data that we have in a table format. So it has an ID of the student, and we have the last name and also the first name. So as you can see, the table is ordered according to the ID of the student. So in this case, if you want to do some query according to the ID, then in this case, the query can be benefit from the binary search. So the query performance will be improved. But however, if right now you want to search according to the last name or the first name, because the table is not organized according to those fields, then in this case, the query can only be executed with the linear search. So in that case, the performance will be O of n, then which is not a very good performance. So in this case, what we can do is to build an index. So for example, if we know that we want to improve the query performance when people try to query the last name, then in this case we can choose the index. We can choose to build index on this last name, and that last name is also will be used for the index field. This last name will be used for the index field. So the index that you are going to build is as the left-hand side table shows. The index field is the last name field in the raw data table. So and according to the definition, the index field it will be the ordered value of the indexing field. So in this case, we are going to extract all the last name and then to order it according to the alphabetical order over here. So which means that from A, B, C, D to X, Y, Z. So as you can see, after we extract all the like values from the last name field, then the first one becomes the C, the Cumberbatch, and the second one is DiCaprio, and the third one is the Downey Jr. and Johansson, Lawrence, and Watson. So as you can see, the index field it has been ordered. And then the second field is called the pointer field, and this pointer field it contains the address to the data that to the raw data field containing the particular index value. So which means that the pointer it looks like this. So as you can see, this Cumberbatch index it will link to the data that has this Cumberbatch as the Cumberbatch as the for the indexing field, which will link to the data block of these records. The data block of this record, and for the DiCaprio, it will contains the address linking to this DiCaprio data block over here, and like Johansson will link to this one, which is the Scarlett Johansson, and then Watson will link to this, which is the Emma Watson over here. So this is the this is the structure of an index. So you can choose to, as you can see, you can choose to build the index on any attributes that you want. If you feel that this is an attribute that the user may set some query criteria on, then in this case you can build multiple attributes on this table. We can build, for example, like here, we can build an index for the last name. We can also build an index for the first name as well. So in this case, when people search according to the last name or first name or both of them, then you can benefit from the indexes because with the indexes, you can perform the binary search on this index field. So as you can see, the index field has been ordered, so we can perform the binary search on them. So that's what we well that's the you can say the structure of an index, and also that's how it benefits the query performance. So, and for large, so basically, but however, the for large data file, the index file may be placed on the disk in many blocks. So, as you can see here, it is a very small data set. So we can easily put this index into the memory. So you can keep this index in the memory, and whenever you need to query according to the last name, then you can just pull it from the memory and then execute the binary search. But however, if you have a lot of last names, and then in this case, the of course the index structure over here, it will grow and grow, and then eventually this index will be larger than just one data block, or will be larger to put in the memory of your computer. Then in this case, you probably need to place the index on the disk in many blocks. So, when after you do that, then that means whenever you need the index, you also need to retrieve those index information from many disk blocks, and that becomes the overhead of using this index. So one of the solution to address this issue is to further create the indexes, create index on those indexes. So and this will becomes the principle of the multi-level index, right? And this multi-level index is kind of like a tree, or it's kind of like a tree structure. So just to give you an example, so if this index over here, originally we create the index on the last name. So but however, there will be a lot of last names, and then eventually there are too many last names in the world, and then you will have a index that is a little bit too large to fit in the memory, or to fit in one disk block. So in this case, maybe we can create another index. Maybe we can create another index to index the specific attributes of this index field. So for example, what we can do is if we right now only index the first character for the first character of each of the last name. So let's just say the first character right now here is C, here is D, and here is J, L, and W. Then in this case, we can create another label of index, which is just like A, B, C, D to X, Y, Z. And those A, B, C, D, X, Y, Z, they will have a pointer pointing to the first record of that first record starting from those characters. So for example, for this case, if the DiCaprio over here is the first record for these for all the last names starting from the D, then in this case, the index field D will have a pointer pointing to the DiCaprio. Then we know that all the last name with starting from the D will be inside this will be just follow after this DiCaprio last name, and then you can do some linear search to find them, or do some binary search to find the specific last name that you want to find. So basically, that's about how you can create multi-level indexes. So which means that you create another index on the index field, and this index field is an index for another field of your raw data. So it's a kind of like it becomes a multi-level indexes. So, like I mentioned, this type of multi-level index is kind of like a tree structure, starting from the root to and start growing and growing, and to eventually to the leaf nodes of the raw data. So these indexing tree structure becomes more and more complex, and then in this case, maintaining the index structure, it will be time consuming, and it will have some complicated management. So in this case, some tree structures are, you can say, directly implemented or supported by the DBMS systems as one specific, you can say, atomic structure. So, and that atomic structure supports different operations. So, those operations can allow you, for example, like the insertion and deletion of some certain data. So, what I'm trying to say is that sometimes some famous tree structures has become a certain, you can say, data type in the database management system. So it becomes self-contained. So when you create, when you specify, say, I'm going to create a certain tree structure index on a certain raw data field, then you will have that tree structure, and it's you can say it's just one. It is represented as one object, and then you can directly communicate with that object, although inside that object is a tree structure. But however, for human beings or for the developer, they don't need to take care of those the details of those tree structure, how those data are queried inside that tree structure. You just need to communicate with this abstracted object. Then in this case, it will become a data independent implementation. And for the programmers or users, it can easily achieve the insertion and deletion by just using a certain operation supported by this tree structure or tree indexing tree structure. And then usually those tree structures, they should be well balanced for the good performance. And the meaning of the balanced tree or non-balanced tree will be further explained in the following content. So in general, here we introduce the idea of the index, and also the physical the structure of the index, and then we also mention that just one level of index may not be enough, and we may need a multiple level of index, and that multiple level of index is what we call the index tree or indexing tree structure, and also finally we mention that those tree structure is sometimes some famous index tree structure are represented as one self-contained and data independent object, and so that it's easy to communicate with. So and later on we are going to introduce some of the famous indexing tree structures, including the one that is used for the general one-dimensional data, and also the spatial access methods, the indexing tree structures for the two-dimensional or multi-dimensional geographic data.